Up until now, we have been starting these nodes up, and if you'll notice, every time it starts with a new ID. Well, if you want to have an ID that is well known to be able to provide a multi-reference to that on a public internet, for example, when you want to set up a relay server, which we'll be getting into later, then the ID can't be changing from on every startup. So what we want to do is we want to generate a private key, and then we want to utilize the ID from that private key using the libp2p libraries. So what I've done is I have gone ahead and I've created a couple of commands. I've added this generate key command, all right, and I have added a key info command. So the generate key command just basically starts off as a Cobra command. We've encapsulated all our logic into a separate little private class struct. Um, and in here, this struct just has some basic, member variables and a couple of functions. A new key generator is a private method within this command, and that key generator will take the parameters that are passed in along the command line, and it will parse those out and validate those and ensure that everything is hunky-dory. And then it will go down and actually generate a key. And there's not a lot of code in our logic here. We're basically, switching on two kinds of keys. We just have to do this bit of translation with a switch case statement to generate a key pair for ECDSA type. And or any other type, we just need to have the key type and know the bits for an RSA key. And then once we generate those things using the crypto functions that are provided by libp2p, we output the keys. We just save them and basically output the ID, and then we save. I've written this little utility method in a utility package, which just basically marshals the key again using the crypto library, encodes it with base 58, and writes it out to an output file. And we also have a function to load that key in later, which is then used by the key info to load the private key, extracts the ID from the private key using the libcrypto, and then prints it out. So let's just see this in operation really quick. And so we're going to go ahead and pbese-help. All right, and we have the generate key and the key info. So we're going to go with key info help or generate key help. And in here, as you can see, you have options. You can choose the kind of curve that you want. You can choose the kind of key that you want. The supported types are ED2551519, ECDSA, which allows you to pick one of these curves right here, RSA, which allows you to specify either 1024, 2048, or 4096 bits. The default is an ED25519 key because it's very short and small and easy to pass around, and it's pretty darn secure. So let's go ahead and do that. We're just going to generate the key with a type ED25519. And it did it. So it saved the key into this private key file, and it printed out the ID. Later on, if you forget what this ID is, but you know where your private key is, and let's just take a look at the permissions on that. As you can see, the private key is saved off here, and one of the things that we need to go in and fix really quickly is the permissions for that, because we don't want it to have those kinds of permissions. So generate key, and in here we're going to save the private key, and it should have written that file with file mode, with a 600 file mode, and it did not. So we'll have to look into that later. But once we get that, actually we can go ahead and fix that code now. Write file. Open file, read only, permissions, file mode. It's regular file. Close. Well, for security reasons, you should actually change that file And I'm going to go ahead and do that now. And then I will, when I publish this code, we'll have a bug fix in that. I don't want to waste a bunch of time troubleshooting a small bug. But as you can see, it's always good to test and demo. So ideally, and it could be that it's Windows too. I'm running Windows, which is not a real Linux POSIX operating system. It's just sort of pseudo POSIX. And of course, you see, it isn't supported on Windows. This actually, on a Unix system, this would have been written out as 600, and you would not have any read permissions unless you were the actual user for that key file. And that would be the only security that you have on that file because it's not password protected or encrypted or anything like that. So it would just need to be protected by the operating system permissions on that file. So when we want to look at the file later, we're going to do a key info. And as you can see, it prints out the ID, which is the same ID as up here, C4MX6, 12D3, 12D3, C4XMX6. And so this will be handy later on when we go to start up servers on a public internet that can then be referenced as sort of anchors on the peer-to-peer network that allows people who have intermittent connectivity to find a way to connect to other people on the network that are also with intermittent connectivity. At some point, you need some anchors in the system so that people can find each other, and that's where relays come in really handy. And that's all for now. Oh, by the way, I'd like to remind you to please like and subscribe if you find these very helpful or helpful at all. Your participation in the channel is most appreciated. Obviously, open to feedback. If you would like to see more of something or have a better explanation of the code or any of that nature, obviously feel free to write comments and make requests. Thank you very much.